Welcome to Solving Systems of Equations by Substitution, Part 2. And the only difference with Part 2 is that we're going to take a slightly more complex problem. And the only reason it's more complex is that last time, this problem, you see the first step here, solve for one variable and at least one equation. We didn't have to do it because we already got two equations that started with y equals. But in this one, neither of these equations is solved for y. That means that or x. So they're both variables on the left, and there's some numbers on the right, but there's no solution for either one. So we're going to have to do that step. So let's go ahead and get started. Now I'm actually going to take this second equation and convert it into, I'm going to solve it for y, which means I want to end up with y equals something on the, y equals on the left, and then the rest of the stuff on the right. So to do that, I'll take this equation here, I'm starting with this one. I'm going to add 8x to both sides. And when I do that, over here, these 8x's, positive 8x and a negative 8x will go away because they'll make a 0. And they'll bring down the y. And then with 10 and 8x, I can't combine them because they're not like terms. All I can do is list them both as separate terms with plus sign in the middle. And so y equals 10 plus 8x. So once we've done that step, we need to do the second step, which is to substitute the resulting expression into the other equation. What that means is, so the other equation is 6x plus 2y equals negative 24. And in order to substitute, where there's a y in this equation, I'm going to replace that with this expression for y. Y equals this too, because we just solved for it in the second equation. Now we're going to substitute that into the first equation. Let's see what happens when we do that. So we'll say 6x plus 2 times 10 plus 8x. Remember, if it has 2 in a parentheses, it's 2 times whatever's in the parentheses. And that's going to equal negative 24. Negative 24. So when you have 2 times what's in the parentheses like this, we have to distribute. So we're going to take 6x, that's going to stay the same. Then we'll say plus 2 times 10, which is 20, plus 2 times 8x, which is 16x, equals negative 24. Now you see by doing this substitution here, you notice how there's no y in this equation? So we've successfully eliminated the y by making that substitution. That's exactly what we want to do so that we can have one equation that we could solve for x, and then we'll go back and figure out what y was. So when we do this, we can collect like terms. So the 6x and the 16x are like terms. 6 plus 16 is 22x, and that's 22x plus 20 equals negative 24. And if we then subtract 20 from both sides, over here we're going to get 22x because 20 minus 20 is 0. And on this side, we're going to take negative 24 and subtract another 20 from it. So I always like to think of it this way. There's a 0, then there's a negative 24, and in order to subtract 20, we have to go 20 more in the negative direction. And as you do that, then you're going to get a larger negative number. In other words, a negative number with a larger value, meaning it'll be negative 44. And that's good because when you divide both sides by 22, you're going to get x equals negative 2. So now we got x equals negative 2. And now we're going to take that and solve for y. Again, we're trying to define a ordered pair which satisfies both equations. So we'll say negative 2 is the x value, but we don't know the y value yet. Let's pick one of these equations. I guess I'll pick the first one and substitute this value in where it says x. So we'll say 6x plus 2y equals negative 24. Now let's do the substitution. 6 times negative 2 plus 2y equals negative 24. That'll be negative 12 plus 2y equals negative 24. And then when we add 12 to both sides, we'll get the negative 12 and the 12 will make a 0, so we just leave that out. And then we say plus 2y, positive 2y equals You have a negative 24 this time, and now we're adding 12, so it's going to get less negative, and we'll end up with a negative 12. So 2y equals negative 12, divide by 2, and y equals negative 6. But we're not done yet, because now, if we've done everything right, this is the solution, negative 2, negative 6. But we're not going to know that until we double check our solution. And the way we do that is we will write these equations, 6x plus 2y equals negative 24, and negative 8x plus y equals 10. But we will substitute in the values of x equals negative 2 and y equals negative 6. So let's do that. 6 times x, which is negative 2, plus 2 times y, which is negative 6, equals negative 24. Let's see if that's true. 6 times negative 2, negative times a positive is negative, and it'll be 12. And then 6 times and then 2 times negative 6, another 12, negative 12. If you add negative 12 and or if you subtract 12 from negative 12, you're going to get negative 24. So we know that the ordered pair negative 2, negative 6 satisfies the first equation. Now we got to do it to the second equation. So we'll say negative 8 times x, which is negative 2, plus y, which is negative 6, equals 10. Let's see if that's true. So we will do negative 8 times negative 2 is 2 negatives multiplied makes a positive, and it'll be 16. Minus 6, because plus a negative is the same as minus 6, and it equals 10. Well, let's see. Does 16 minus 6 equal 10? Yeah, yes it does. So now we know that negative 2, negative 6 satisfies both the first equation and the second equation, so our solution is correct. And that is solving systems of equations by substitution, part 2.